little bit about myself. My name is Stuart Scott, and I'm one of the trainers here at Cloud Academy, and I specialize in AWS. If you have any queries or questions about anything I'm speaking about today, then feel free just to contact me with those details on the screen, and I'll be happy to get back to you as soon as I can. Okay, so moving on. What are we going to be talking about today? A quick agenda overview. So we're going to be talking about security in the cloud. In this section, we're going to be explaining why security is important, why it's important to so many people and organizations, and we'll look at how it's different to on-premise security, so the differences between the cloud and on-premise security here. And I'll also talk a little bit about the Information Security Management System, so ISMS. So we'll cover that as we go through. We'll then talk about AWS Shared Responsibility Model, and this is where we kind of discuss where the roles and responsibilities change between AWS and what they look after and manage with regards to security, and what we, the end users, are responsible for from a security perspective. I'll then give an overview of some elements to do with VPC security. So here I'll explain about security groups, network ACLs known as NACLs, what an internet gateway is, Bastion Host, public subnets, etc. So we'll cover those details in that section. And then I'll provide a demo showing how to architect a lot of this infrastructure within AWS. What I'll do after the demo, I'll open up for some questions if we have any questions on the demo and anything about that I showed you. And then depending on time, we'll have a look at some of the AWS security services that AWS provides. So we can look at the Web Application Firewall, WAF, Inspector, Identity and Access Management, and also Trusted Advisor. At this point, I'd just like to do a quick poll just to find out who, out of these services, which you know least about. So I'll just launch that poll now. So if you could just select which of those 4 services you know least about, and depending on time later, I'll try and address those. Okay, so security in the cloud, why is it important? If I ask this to many people, the first thing they'll probably come back is it's important because they want to protect their data and customer data from malicious attacks. All too often we hear about breaches within large organizations where a hacker got into their systems and stole vast amounts of customer data, and it was stolen. Essentially, if you don't apply correct security, your organization can have their data stolen, which would ultimately lead to their reputation being negatively impacted. And as a result of that, you'll lose your competitive edge within the market. And on top of all those, you'll also suffer from financial losses through loss of business or fines from your customers. Obviously, with cloud security, you don't have as much control. Some of the control has been removed, and this has 2 effects. Firstly, it's a cause for concern for a lot of people, and it's one of the main reasons why some organizations are yet to adopt cloud security. They're concerned about where their data is. They don't know exactly where their data or where their customer data resides. They may know the region or availability zone, but they won't be able to pinpoint exactly where it exists. And the other effect is, because people who have migrated to the cloud, they're aware that AWS do provide a lot of security, back-end security and security services, people become a bit too complacent. People think, okay, I'm using their services, I've been told it's resilient, I've been told they apply some security, and they leave it as that. They become too complacent with their data, without realizing that they need to architect some of their own security on top of that. So it's one of the main reasons is, why is it important? You need to restrict it from unauthorized people from accessing your data. But on the other side of that, and it's kind of often overlooked as well, there's other points and factors of why it is important. There may be certain legislation and regulations that you need to abide by, or legal compliance. You may have data that may need to remain in a specific country or location. You may need to comply with certain governance, such as ISO 27001, or you might need to be PCI compliant. And this might be set up in your service level agreements, your SLAs, or within your customer contractual agreements. And failure to comply with this compliance, when it comes to an auditing perspective, it could have significant detrimental effects on your business and customers. Another aspect, speaking of customers, is they may have certain requirements on how their data is stored. They may want it to be encrypted, whether that be at rest or in transit, and they may have specific encryption protocols that they want you to abide by. So, although the first thing when you think of why is it important, you think, I just want my data safe, there are other aspects. So kind of three areas. Restricting unauthorized people from accessing that data. There may be legal reasons with regards to the location of data, and customer requirements. So it's important to take all those factors in when you're thinking about security within the cloud. So how is it different to on-premise? Just a couple of high-level overview points here, really. With your on-premise solution, you have more responsibility as an organization because you have full control over the estate of your infrastructure, allowing that finer-grained control that you can have. It's all accessible to you, which is the main difference. You can control access, who's got access to your facilities, to your buildings, to your data center, who can access your technical halls, who is authorized and trusted to perform some of the installations and maintenance for your infrastructure. And you can resolve all the issues yourself. It's all self-contained. However, in AWS, this aspect of the security is taken away from you. We aren't allowed to gain access to their data centers, to their availability zones. It's just not allowed. So also with your on-premise solutions, you can specify exactly where your data is stored. You'll know which customer data is in which data center, which rack, even down to a particular SAN. You have full visibility of that storage and where customer data is. Whereas in the cloud, you don't have as much control. You know roughly where it is, but not precisely. And when it comes to business continuity and disaster recovery and items such as offsite backup management, that whole process is down to you to architect within the facilities that you have. Within AWS, much of this is handled by design from their global infrastructure and their resilient services. So there's a couple of key differences there that you need to think about. Some pros and cons for both. But there's definitely a split of roles and responsibility, but we'll discuss that more as we go through the webinar. Now, your Information Security Management System, your ISMS, most organizations will have this document in one form or another. For those of you who aren't aware with what this is, it's essentially a set of controls and policies that dictates the security requirements within your organization. So it looks at what kind of risks your business has from a data perspective, which data you need to control and protect, and the requirements around those controls. Do you need to encrypt that data, depending on how confidential or sensitive the data is? When do you need to encrypt it? Just at rest, in transit? And then also be a number of policies within your ISMS as well, such as a password policy that will define standards such as which characters are allowed and how long those passwords need to be and when they need to be rotated. Another point with your ISMS is, can this work with the cloud? Will it have to be modified? Who will have to modify it? Is it compatible with your current set of security controls? Can you use that within the cloud, or will it have to be modified? More often than not, the cloud, using cloud security and AWS security, you can enhance your information security management system through the many different security services it offers and the different configurations that you can use. So how does AWS manage security? Essentially, AWS manages security through a shared responsibility model, which is what we'll be talking about next. So let's crack on. What is AWS shared responsibility? It's a model where AWS assumes a part of the responsibility for security of your data, and then the rest of it is up to us. So it's shared between the end user and AWS. It's a top priority for AWS. Security is their top priority, and they pour a huge amount of capital in security to ensure they're releasing new services, fixing new bugs, ensuring your data can be as secure as possible. So what are they actually responsible for? What are AWS responsible for? Looking at the global infrastructure, such as their regions, the different availability zones within their regions, and the multiple edge locations they have around the world, they are responsible for the global security of the cloud. This back-end infrastructure makes up the cloud, along with their AWS Foundation services. But they need to ensure their sites, their facilities are protected both externally and internally from any kind of threats. And they also have to look after all the mechanical and electrical infrastructure, such as generators, UPS, crack units for their air conditioning and fire suppression, and ensure they maintain the uptime of those facilities. So moving on to the AWS Foundation services, such as compute, storage, database, and network, they operate a certain level of security on each of these components as well. If we take a look at the compute, for example, they will manage the security of the actual physical host up to the hypervisor, and that's where they'll stop at that level. Anything on top of that then becomes our security issue. Another example from the network perspective, they monitor for unusual and suspicious activities at different ingress and egress points of the AWS network, looking for DDoS attacks, IP spoofing, and any unauthorized port scanning as well. So there's a lot of back-end security elements that AWS maintain and monitor to help ensure that our data is safe. Looking at what we're responsible for, it's essentially everything else on top of that. We're responsible for security in the cloud. So looking at our VPCs, for example, we'll be responsible for configuring security groups and network ACLs from a firewall perspective. We'll be looking at hardening our instances, our OSs, making sure they're all patched with the latest patches, setting up key pairs for decrypting logon information. We'll decide where our customer data exists, what country and how it's stored, the location, and which AWS service we want to implement and when, and configure those services for certain resiliency. For example, we can use RDS multi-AZ. That service is there, it's not configured by default, it's down to us to architect to implement that resiliency. And of course, we have to look at all the identity and access management. So we have to set up all the users, groups, roles, permissions, setting up usernames and passwords, setting up multi-factor authentication, access keys for API calls, etc., etc. So there's a lot of elements that we have to take responsibility for. AWS provide a lot of the back-end security, but then there's a lot of elements that we have to control and monitor ourselves that AWS do not control. And this responsibility is very dependent on the service type. So just going back here, that's very much from an infrastructure level. For example, you've had on your EC2 kind of hardening your OSs, etc., setting up your security groups. and everything on top of that. From as another level other than the infrastructure level, a container level. So here we're looking at services such as RDS and EMR, which are managed services typically running on top of EC2 instances. And here AWS need to accept a greater responsibility because we don't have access to the underlying EC2 instances here. So they will ensure they are secure, they are patched, that the RDS, whether it's MySQL, etc., is all patched to the latest security because it is a managed service and we don't have access to those components. And then finally, there's another level, which is an abstract level. And these are services such as SQS and SNS. So here AWS is responsible for the service components and all the underlying architecture behind this. So the platform, the OS it runs on, etc. And for these services, we're just mainly presented with endpoints for APIs, and it allows for minor configuration. So it depends on what service you're using, will depend on how much responsibility AWS has and how much responsibility you have. So looking at VPC security, firstly, the virtual private cloud, what is a VPC? A VPC is essentially a logical isolated section of the AWS network. You can set up your own IP address range, create private subnets, public subnets, implement route tables, add internet gateways to get access to the internet, etc. So it's your own private address space to enable you to launch other AWS services on top of if you need to. Security groups, they act as the same way as a firewall does, really. They look at security at the protocol and port level. And security at an instance level. So these are applied to instances. There's no deny within security groups. So if there's a packet comes in and a rule doesn't match that packet, then it's just dropped at that point. It's made up of a type, protocol, port, and source fields. The type is typically just the protocol you're using, SSH, HTTP, or you can set it as all TCP ports, etc. The protocol, again, you can specify the protocol type, TCP, UDP, etc. if you have a custom type. The port range is always the port of the protocol you're using. And then the source, that can be a subnet range, a specific IP address, or in fact, another security group. An important point to mention about security groups, they're stateful rules. So you don't need the same inbound as you do outbound. And then you have network access control lists, NACLs. Now these pretty much work the same way as security groups do, but they work at the subnet level. There's a couple of differences here. You'll notice that there's a rule number, and also you're allowed to deny traffic. You're allowed to explicitly deny, whereas if we have a quick look back at the security groups, there's no option to deny. So the rule number, this depends on which order the rules are looked in for a packet. So as a packet comes into the network, to the NACL, as soon as it hits a rule that it fits, it ignores everything else below it. So it's important to have your rules in the right order, depending on how you want your traffic to be managed. Okay, an internet gateway. This simply allows you to make one of your subnets public. If you have an internet gateway attached to one of your subnets, so one to your VPC, and then add a route from one of your subnets to the internet gateway, then that subnet then is classed as a public subnet. The internet gateway is a managed service. It's very easy to set up and configure, and it simply allows you to gain access to the outside world should you need to. Bastion Host. This essentially acts as a bridge to your private instances via the network. So it's a primary point of access from outside your VPC over the internet. It will sit inside one of your public subnets and accept traffic, typically SSH or RDP, and you can jump onto that Bastion host from anyone working remotely. So it's great for out-of-hour support guys that need to gain access to your private instances. What they'll do, they'll connect onto the Bastion host, like I say, via SSH or RDP, and then from there use that as a jump server to gain access to your private instances, again via SSH or RDP. NAT instance, that also sits within a public subnet, and that allows private instances to initiate outbound requests to the internet. So you'll have your private instances that don't have access, that are kind of nestled inside your VPC and inaccessible from the internet. But what it allows them to do is to connect to the NAT to then pull information down from the internet. So it's great for when you need to do patch updates, etc., to your private instances. Okay, and now we've reviewed some of those components. This is what we're going to be doing in the demo. We're going to be setting up a VPC, and we'll be using two different availability zones, creating two subnets, a public subnet and a private subnet. We'll then set up some security groups, again, one public, one private. We'll then configure a Bastion host and a private instance within the private subnet. So that's kind of what we're going to do, and I'll show you the steps on how to achieve that. So firstly, we need to create our VPC. So let me flick around. So if we find the VPC, nice and quick. Now there is a VPC wizard that you automatically set up a public and private subnet for you. I want to create it from scratch so you can see exactly how it's architected. So and I want to create a new VPC. Let's call it Cloud Academy. Give it a cider block with a 16 mask. So that 10.0.0.0 will be our network address space for VPC. So as you can see, we have our VPC cider address range 10.0.0.0/16. Okay, so we now have our VPC. Very easy to create, very simple, not much more than that. Next, we need to create our subnets. So we want a public subnet and a private subnet, one in each availability zone. So go to subnets, create that, give it a name, give it a public subnet name, select the VPC that we want this subnet to reside in. So that's Cloud Academy, which is the VPC we just made a moment ago. Select the availability zone that we'd like, and then give it a network address which falls within our cider range that we specified for our VPC a moment ago. Now I'm also going to create the private subnet. select the Cloud Academy VPC again. I'll give this a different address space. Okay, so we now have our VPC and our two subnets created. So we've got the public subnet here, 10.0.1.0, and our private subnet with 10.0.2.0. So next, we need to create our internet gateway. So we need a way of accessing the internet from our VPC. So if we go to our internet gateway, create internet gateway, just need to give it a name. So internet gateway, Cloud Academy, create. And you can see that it's detached at the minute, so we need to attach this to a VPC. So click on attach to VPC. It already has our VPC Cloud Academy selected, and say yes, attach. So we now have our internet gateway attached to our VPC. Next, we want to create some route tables. So we will create a route table from the public subnet out to the outside world via the internet gateway, and we'll create a private route table to allow the two subnets to talk to each other. So if we go to route tables, create route table. Public route. Associate that with our Cloud Academy. Go to the route. We need to edit this and add an entry for traffic going outside of our VPC. So 0000 via our internet gateway. Here we go, internet gateway Cloud Academy, which is what we just created. So any traffic not destined for our local network will go via the internet gateway. And this is for our public route. Now we need to associate that to our subnet. So let's associate that to our public subnet. At the minute, it's got the main routing table, but we're creating our own routing tables just to make it a bit easier. Okay, now we're going to create a private route as well. Now, Cloud Academy VPC. Now, this route here, that's fine, because all this will do is talk to any other subnets, and that's all we want. We don't want any outside access for our private route table. So that will be able to talk to all the subnets on the 10.0.0 range. But we do need to associate that with one of our subnets, our private subnet here. Okay, now have our routes set up between our subnets and the outside world. Next, we'll create our network ACLs. So we'll create a public NACL and a private NACL. So if we go into security section, network ACLs, create network ACL. We'll do the private one first. On the inbound, so we'll say, let's allow, for this demo example, we'll just allow all TCP traffic coming from the public subnet we shall allow. So from a network level, any TCP traffic coming from 10.0.1 will be allowed into the private subnet. Also need to specify the same for the outbound as well, because it's stateless. So all TCP traffic going to the public network we shall allow. And then we shall associate that to our private subnet. And we'll do the same for the public as well, but this will be slightly differently. So this will be our public NACL in our VPC. So firstly, I have all TCP traffic coming from my IP address, because I'm going to want to jump into the public subnet to access the Bastion host. I need to on the mask. And I want to add another rule for the private subnet to talk to the public subnet. And again, add it for outbound as well. Forgot the mask again. Oh. Okay. Associated to the right subnet. So we want that on our public subnet. That's our public NACL. So now we have our NACL set up. So we have all TCP traffic allowed from my IP address coming into the public subnet, and also TCP traffic between the two subnets. Next, we want to look at the security groups. So if we go down to security groups here, create a security group. We'll create a public security group. This will be used by the Bastion host. So we have two security groups, one public and one private, very similar to the NACLs. But remember, the security groups work at the instance level, and these will be associated to our EC2 instances that we'll be launching and creating shortly. So just create a private security group used for private instances. So we've created those security groups, but now we need to just configure the traffic on them, the rules. So looking at the private inbound, we'll be more specific this time. We'll say just traffic, and we'll say anything from the public security group. So anything coming from the public security group is allowed to access this security group via RDP. Now if we look at the public inbound, we want RDP coming from the private security groups. and also the RDP coming from my IP address. So I'm going to be jumping onto the Bastion host, which would be residing in the public subnet, which will have the public security group associated. Again, forgot the mask. Okay, so we now have our two security groups created, our private and our public. Now we need to create our Bastion hosts. So let's go to 82. Just launch an instance. I'm just going to Windows box for this. It's running very slowly, I do apologize. So I'm just going to pick a very simple instance for this demonstration. So this, need to select our Cloud Academy VPC. This is going to be our Bastion host, so we want it to sit in our public subnet. We want a public IP address because we'll use that to connect to it over RDP. Let's name this instance Bastion host. Configure the security group. Now we've already created the security group, so let's select one here. So this will be used by the Bastion host. This is our security group that we want to use. And as you can see, it will accept an RDP connection from my IP address and also from the private security group. So let's review that launch. Now it's asking me to create a key pair here so I can decrypt the login information. We'll create a new key pair. We'll call it demo. So this will allow me to actually connect to the instance. Launch. Okay, so that's our Bastion host created. While that's running, we'll now create a private instance that will be situated in the private subnet. So let's go back to EC2. Just quickly, just to show you that the Bastion host is up and running. So now we'll launch our private instance. So very similar again, just going to select Windows, configure the details, Cloud Academy VPC. Now we want it in our private subnet. We don't need a public IP address because we don't want it accessible from the internet. So we'll just use our private IPs. Now we'll tag this as our private instance. Go on to our security groups. We've already created a security group. Here it is, used for private instances. And this will allow RDP from the public security group. So once we've connected onto the Bastion host, which is in the public subnet, we'll then be able to RDP onto this instance because we have the rules set up here. So let's review that and launch. We'll choose an existing key pair, demo. And that instance is now being launched. Have our two instances there. The private one's just kind of booting up now. So what's next? Passwords. So this is where we use the key pairs that I downloaded to get the password for our instances. So firstly, select the Bastion host, get the Windows password, decrypt Oh, sorry, it's not available yet. Trying to do it too quickly. We've done so far. We've created our VPC. We created our subnets, both a public subnet and a private subnet. We attached our internet gateway. We then added our routes to those subnets and associated with the subnet. And then we set up our network access control lists. We then set up our security groups, and we've just launched our instances, and we just need to get the passwords for these. Here we go, that's ready now. So there's our key. So we'll just copy that for a second. Okay, so now we've got the password of the Bastion host. We can test our connectivity. Okay. Sorry, just bear me one moment. Where did we get to? Okay, test connectivity. So on an RDP to the Bastion host. Now we need the IP address of our Bastion host, which we can get public IP address. So we'll copy that into our RDP client. Connect as administrator. Have the password. And this is our Bastion host. Okay. So hopefully this should connect through because we've set up the NACLs. So from a subnet level, I've allowed my IP address access to the public subnet. And from a security group perspective, I allowed my IP address to have RDP access to the Bastion host. So as long as the demo gods are working with us, this should connect through. And there you go. So this is our Windows server that we launched. This is our Bastion host. It's just connecting as administrator using the password we used, and it's just creating the profile. Now, one of the downsides is using Windows in this example. It does take a couple of minutes more, but I see a lot of demos with Linux, so I thought I'd change it up a bit today. So it's just creating the profile, and it should be connecting very soon. And there we go, we are on our Bastion host. We have successfully connected via RDP from my laptop. So now we want to, from this Bastion host, we want to jump across to the private instance as if we was dialing in from home and going on to support some private instances within the VPC. So first we need to get the password, like we did with use our key pair demo. Use the file. Where's my session gone? So from our Bastion host, we want to connect through to our private instance. The IP, we'll use the private one because that's all that we have, so 10.0.2.13. We'll connect as administrator. Okay, so we'll just enter our password. So, maybe 4. So, done that right. So, providing I have the NACLs set up correctly and the security groups, that should allow me through onto the private instance. Okay, and there we are. It will just take a second for that connection to establish, but that's let us through to the private instance. So just flipping back to the presentation. So it was on the Bastion host, and we've just RDP'd from there onto our private instances. Just wait for that to come up, should only be a second. Again, in hindsight, maybe I shouldn't have used Windows. It just takes a little bit longer unnecessarily. But I just want to wait for it to fully load so you can see that we have moved on to the private instance. And there you are. We are now on our private instance. So that's worked. That's all that connectivity has worked. The security groups worked, the NACLs work, and the route tables worked. So at this point, I just want to ask if there's any questions. You may have been typing some questions in the window, but I just want to take a few minutes here just to answer some of the questions. I'll just take a little look to see if any have come up and if I can answer some of those. So let me just take a look. Just bear me one moment. So we've got a question here to do with network ACLs with regards to the rule number, how it's defined. Is it the rule number that it's defined by, or the order in the user interface? It's defined by the rule number. So it will start off at the smallest number first, and then go up. It's a good idea to add some gaps between each of the rules that you add, just in case you need to add something else in between, and you can kind of fill it in between. So I tend to leave a gap of between 50 and 100, and that allows you to scale up and down. Got a question here with regards to what a Bastion host is. Hopefully it's a little clearer after that demonstration. But it's essentially a hardened box, an instance that will sit within your public subnet and allow external people to connect to that box via SSH or RDP or any kind of other secure means. And then from there, using security groups or network ACLs, establish a connection to other private instances within private subnets that don't have an external IP address. So it's just a secure way to access your private instances over the internet. Just taking a look at some other questions here. So just bear me 1 second, just scrolling through. Can the Bastion host be used as a NAT instance as well, or vice versa? No, they're two different kind of instance types and configured differently. So, like I just said, I just explained what the Bastion host is, but the NAT instance, although it sits in the same public subnet, it handles kind of port forwarding differently. And the NAT instance allows your private instances to access the internet, but without an initiation being established from externally first. So they're two very different instances, and I would tend to keep them that way. AWS do offer an AMI and also a managed NAT service now. So if you're looking to implement that, then I'd certainly look at that. There's some good documentation from AWS with regards to manage NAT. Okay. What are some of the gotchas to watch out for when setting up a VPC? That's a good question. You want to make sure that your CIDR block range that you start with is big enough to enable you to architect other instances, other subnets within your infrastructure. Because if you restrict yourself to just a few networks, then that may not be big enough for what you're trying to architect for. So be sure to make sure your CIDR block is big enough to then split out into smaller networks, whether they're public or subnet. And also need to be aware of, if you have multiple VPCs, you can configure VPC peering, where one VPC can see resources in another VPC. When you're doing this, you need to be sure that your CIDR block ranges do not overlap, because if they overlap, then you won't be able to configure that correctly. So that's certainly something to watch out for as well. Now, there's a lot of questions coming up here. I'm not going to be able to get through all of them, unfortunately. But we will have a section, or we do have a section on the Cloud Academy community site called Cloud Security. So any questions that I don't get through today, because there are quite a lot, we will post in our community section, and I will, or myself or a member of the team, will answer those questions for you. Just looking at the time, I just want to spend a little bit of time just reviewing some of the other security services that we have. Just giving a quick overview of IAM, Trusted Advisor, Inspector, and the Web Application Firewall. Like I say, I will take a look at these questions on our community site, on our community forum, and get back to you guys with answers to these. Like I said, there's quite a lot there, so I'm not going to be able to get through them all this evening. So let me just move on from that, and I'll just give you a quick overview of some of these other services. So IAM, It's one of the most important services when it comes to security. This service primarily governs and controls user access within your AWS resources. It achieves this through different authentication methods and users groups and roles and policies. With regards to authentication methods, typically a user will have a username and password. They might have multi-factor authentication configured, access keys for API calls, or you might even use federated access. So with regards to MFA, multi-factor authentication, that requires a 6-digit random generated number through an MFA device. Personally, I use an app on my phone called Google Authenticator. And that generates a random number every few seconds. So I'll log on, I'll put in my username and password, and then it'll prompt me for a 6-digit number, which I then use my MFA device to gain access. Access keys are generated or can be generated for each user, and are used for making API calls. So if you're using the AWS CLI to configure your AWS services and architecture, then when you're configuring your CLI, it will prompt you for your access keys, your secret key and your access key. Once that's confirmed, you'll then be able to make those API calls with your CLI using the permissions that your user has. And federated access that I mentioned just previously, just quickly, this simply allows external entities to temporarily connect to your AWS resources without requiring an existing IAM user account. This comes in 2 forms: enterprise identity, which allows you to connect to your existing Active Directory for your users, so you can enable single sign-on, or you have web identity. If, for example, you're creating a new game that hits the market and you need millions of users, you can use credentials from Facebook or Google, etc. So users, groups, roles, and policies. Users are account objects that allow individual users to access your AWS environment with a set of credentials specified within the policy. You can issue user accounts to anyone who you might want to view or administer objects or resources within your AWS environment. Permissions can be applied to user, but it's a better practice to apply them to groups. So typically you'd create different groups, apply permissions and policies to those groups, and then add users in or out of those groups rather than to the individual users themselves. Roles, again, are created in IAM, which have policy permissions associated to them. And these can be associated to resources as well, such as an EC2 instance. You could have a role that allows full access to S3, and then when you launch an instance, you can associate this role with the EC2 instance, and that will then have permission to access S3 as per the policy without requiring additional access keys to be stored locally, which is obviously a bad practice to have. So looking at Trusted Advisor quickly, Trusted Advisor is like having your own security specialist looking over your shoulder of your entire estate. It provides suggestions and prompts to make to your AWS environment for additional security, so things you might miss, things you might overlook, and it does this in 4 different areas. It looks at your estate from a cost optimization point of view, a performance perspective, overall security, and from a fault-tolerant design as well. And it will look at your estate and your environment across these 4 areas, and it'll report back using a traffic light system. So red for immediate action required, yellow for investigation needed, and green for all okay and there's nothing to worry about. There's different capabilities depending on what support agreement you have with AWS. If you've just got a standard account with no extended enterprise or business support, then you'll have access to a couple of these features on Trusted Advisor. But to get the full benefit of Trusted Divider and what it can offer, you really want to look at the enterprise or business support package, especially if you have a large estate to look after. You'll really get the full advantage of it here. And it could help you save a significant amount of money because it will check you have the right level of instances, make sure they're optimized, and it'll also check your high availability configurations as well to ensure everything's in place in the event of a failure. So moving on to Inspector. This come about because AWS customers wanted additional help with securing their infrastructure. So this was launched, I believe, at reInvent last year, and it's essentially a automated security assessment service that's repeatable. So you'll install an agent on an EC2 instance. You'll then set up a number of rules and security elements that you want to check. You'll then let that run for a period of time. You'll stop Inspector, and then you'll get a series of results back as to if there's any vulnerabilities there. And if there is, you can fix them, and then you can repeat that same process to ensure that it's cleared. It basically works off, like I mentioned, agents, tagging of your instances, and rules. As a configuration setup, you'll initially install the agents on the EC2 instances that you want to monitor. Inspector will require a role to run. So it will require a security role, and this role will literally have access to describe instances, just so it can look at the relevant tagging information of your EC2 instances. So once your agents are installed and your role is set up within Inspector, you'll then look at the tagging of your instances, and you can specify which compute instances to monitor dependent on your existing tags. So you haven't got to go and set up a whole load of new tagging. You can just use your existing tag information and specify it that way. So once you've selected which instances you want to monitor, you'll then set up your rule base. And there's a number of pre-built existing rule bases that AWS has set up. They look at common vulnerability exposures, so CVE. There's rules for network best practices, OS best practices, and even PCI readiness. So you can see how ready you are to be PCI compliant. They won't say you are compliant, but they will tell you whether or not your applications have passed certain tests, etc. And then once that's all up and running, you've set your rules up, you'll then use your infrastructure as you would normally. This gives Inspector a chance to analyze your applications, your OS, just to see if there's any issues. And then you'll stop Inspector or let it time out after a period of time, and then you can review your results. And within your results, you can check for certain vulnerabilities. It will tell you if it's found a specific vulnerability, and it will often give you a link to a package to help remediate that problem. And once you've applied all your packages, like I say, it's then repeatable, and you can repeat the process until Inspector finds no more issues. Finally, Web Application Firewall. This is used to protect your websites and applications against malicious attacks. It was launched at reInvent 2015, and it sits logically between the public users and your web services effectively. And you can configure it to either block or allow requests depending on what rules you have configured within it. And it monitors for security events, and it's closely linked with CloudFront distribution lists as well. So when configuring and setting up your WAF, you'll create something that's called a web ACL, a web ACL. And this is comprised of conditions and rules. The conditions can be things such as IP matching. So if you want to block or allow a specific IP or network range, or you can look at strings in HTTP headers and block or allow depending on what those values are there. And then you can, once you've configured your conditions, you can set up a rule to, like I say, either allow or deny these conditions through. And then when your web ACL is set up and configured, you can then apply that to a CloudFront distribution. So when someone goes to access your website, it will hit CloudFront. It will then look at the web ACL, and depending on what conditions and rules you have defined in there, the packet will either be dropped or allowed through onto your website. A neat feature with WAF is that you can configure alarms as well. So, for example, if you meet a certain threshold of hits against a particular rule that you're concerned about, you can be notified via a CloudWatch and an SNS to send an alert to your security team. So that's just a quick overview of some of the security services there. I know I've kind of overrun on this webinar, and I do apologise. But that brings us to the end of Cloud Academy. I've run out of time really for additional questions, but like I say, we do have a link on our Cloud Academy site under the community section for cloud security, and I'll be posting all the questions there and answers from this webinar, so be sure to check it out. Apologies I didn't get a chance to answer more. I would have loved to. I was just worried about the time factor for you guys there. So thank you for attending this webinar. It's been great talking to you today about some of the security features and VPC security. Also keep an eye out for any other webinars that we have coming up using the link on screen. That's the top link there. And also, if you're looking to train your team, we offer a live demo of our enterprise product, and you can access that on our second link on the screen there, the enterprise cloud computing. So if you're looking to train a team within your business, then be sure to check that out. And finally, the last link there, if you're just an individual user looking to gain more information about cloud computing, whether it be AWS, Azure, Google, then there's a free offer on that link as a trial, a free trial period. So thank you very much again. Like I say, this has been recorded, so the link will be sent out to everyone attending. And thank you and goodbye.